Welcome, Dr. Manoj Karkee. Thank you for interviewing with us.
These objects. How difficult it is? It's always challenging in outdoor environment because in outdoor environment it's different than industries with that operate inside buildings because we have sometimes cloudy days, sometimes windy days, sometimes direct sunlight going to sensors or cameras. So it's challenging, but in recent years we have made a lot of progresses and we are able to identify more than 95% of apples in these trees. And then from that point, we can find out the shape, size, color of these apples very easily. So that means finding out ripe apples based on color, shape, and size is not a problem anymore. That's exactly how human pickers pick apples. They look at color, shape, and size. However, there is one more component that defines ripeness of a fruit, that is internal characteristics, which includes sugar content, meaning how sweet a piece of fruit is, and they also have other chemical characteristics that are used to define ripeness in addition to external characteristics like color, shape, and size. Those internal characteristics are currently estimated by managers in these farms. They pick a piece of fruit, cut it, and use some chemicals to estimate how much sugar is there. But there are also sensors that can have some level of estimation of these internal chemical constituents of fruit, which could be included in a robot. But in my prototype, we have not included that kind of sensor yet. And I can add one more thing, another couple of seconds here, is that because in modern orchards, almost all of the apples are harvested together one pass, meaning everything is harvested together. And farmers are okay to do that ripeness analysis and let the machine or workers know this is the day you need to harvest. And that day you can send your robot or right now human pickers to do it. So there is that aspect as well. But just going back to your question, Carlee, we have sensors that can do external quality evaluation and ripeness evaluation that are included in our robots. And there are other sensors that could be included to understand internal properties. We always face unexpected challenges, whether that be through burning motor during critical evaluation time or finding that the orchard is so muddy, our prototype cannot be moved around. We need to come back home. There are other challenges that we've faced. For example, we have broken our hand multiple times by grabbing branches rather than fruit because of the inaccuracies in our system when we're developing them. There have been situations where a camera is saying fruit is at XYZ location, but then my conversion system and control system or my brain is telling the robot that the fruit is at some other places because of that calculation problems that we had. So there are so many, in a way, interesting and other way frustrating stories that me and my students have faced during this development. But that's typical of research project. It's nothing unusual. We want young, curious, intelligent kids and students to be interested in agricultural automation and robotics and want them to come to this space because I feel like this is a very, very important area that we want to contribute to. While everything is important, whatever we do is important, but I would like to just emphasize that we want to go beyond our kind of, well, let me put it this way. A lot of our kids, young kids, when ask them where the milk comes from, they often say from grocery stores. We have to go beyond and understand how farming is done, and we have to start to realize the challenges farming communities face, and any way we can support them, eventually we'll be supporting ourselves and the humanity around the world. World population is increasing. We have to increase our productivity, quality, and sustainability of farming systems. Well, those are some kind of abstract aspects of why we want to do what we want to do. Now, with agricultural robotics, such as the ones that you guys are covering, and drones or UAVs, and many other automation techniques that are going into farming, farming these days is not much different than any other robotic systems or automated systems, and they are as interesting as any other fields, in my opinion. And that's why I want young folks to be involved in this area. Now, what you could be doing, Carlee and Dustin, whatever you're doing is great. That's already more than. I was really fascinated to see an email from 6th and 5th graders like you talking about agricultural robotics. That's more than anybody else have done, in my opinion, at that age. But from that point, you could continue to learn mathematics a little bit more, because at the end of the day, everything runs by mathematics. All the image processing systems we develop, the understanding of rightness and things like that you guys ask, those are based on mathematical theories. And on top of that, we need to understand how computers work, how programming is done, and need to understand a few programming languages along the way, let's say by the time you graduate your high school. And then continue some aspects of science, engineering, and mathematics, and you should be there. I think more than anything else, this is your interest in the area or the topic, and that once you are interested, you'll find ways to get there.